Hello, welcome to VVEX Solutions tutorials. In this tutorial, I am going to teach you circle theorems. In this tutorial, there will be 8 circle theorems that I am going to discuss with you. So before starting the circle theorems, I am going to take you through some of the basics of a circle that will be helpful in understanding circle theorems. So the first one is this. This is a chord, and a chord connects 2 points on a circle. A chord divides the circle into 2 segments. So this is the smaller segment, and we call it minor segment, and this is the major segment. You can see the longest chord in the circle is its diameter. Now in this segment, the boundaries are an arc and the chord. Then in addition to that, we define a line called tangent. A tangent, by definition, touches the circle only at one point. So you can see these are 2 tangents, and they just touch at this point and this point, no matter where you keep it. Now I'm going to teach you the first circle theorems. The first circle theorem says the angle subtended by a chord at the center. So this is the chord, and it subtends this angle at the center, is twice that of the angle subtended by the same chord at the circumference. So this chord subtends this angle at the center, this angle at the circumference. So this theorem says this is twice as big as this, regardless of its position. Now if you see it, so I'm moving this, it is still 2 times as big as this angle. And you have also noticed the position D is in the same segment. Now if I move into the other segment, the angle changes. So it's very important note that should be in the same segment. Now I am going to animate it. You can see now it changes back to the same thing. So that's the first circle theorem, and here is the proof. It's very easy to understand. You can see this triangle and this triangle are isosceles. So if this is A, so is this. So this angle is 2A, B, this is 2B. So this angle is 2A plus 2B, which is 2 times A plus B. That means this is twice as big as this. Now I'm going to show you the second circle theorem. And it says the angles subtended by a chord in the same segment are equal. So this is the chord, and it subtends this angle and this angle at the circumference. So the theorem says they are equal. Let's see. Now I'm going to animate it. Now it changes, and it's same again because it's in the same segment. Right, so here is the proof. We have already proved that this is 2 times this angle. So on that basis, you can see this is equal to this. So the third theorem says the angle of a semicircle is a right angle. So this is a semicircle and this is a right angle. You can see I'm moving that angle, I'm moving that point, and it is still the same. So I'm going to animate it. You can see it is still 90. So here is the proof. Circle theorem 4 is about a cyclic quadrilateral. A cyclic quadrilateral is a quadrilateral with all 4 vertices touching the circumference of the circle. Now this is a cyclic quadrilateral, and the theorem says the opposite angles add up to 180 degrees. So you can see no matter where these points are, the angles add up to 180. So that's the theorem 4, and here is the proof. It's very basic proof, very simple, and you will understand it. Circle theorem 5, it says the angle between a radius and a tangent at the point of contact is 90 degrees. So I can move the tangent. You can see the angle remains 90 degrees. So here is the proof of the theorem 5, but it's bit more complicated than what we have seen before. And the theorem 6 says the 2 tangents drawn from a point to a circle are equal in length. So this is the external point, and these are the 2 tangents. So the theorem says these 2 tangents are equal in length. You can see no matter where the point is placed, the 2 tangents are in equal length. Theorem 7 is also called alternate segment theorem. It says the angle between a chord and a tangent is equal to the angle in the opposite segment. You can see even if I move the point, the angle remains the same. So this is alternate segment theorem. I will move it here. You can see the angle remains the same. Now it changes back in the alternate segment and it's the same. So the theorem 8 says the perpendicular line that connects the center and a chord bisects the chord. So this is the center and this is the line that connects the midpoint of the chord at a right angle, and it bisects this line. So this is equal to this, and here is the proof. Okay. So that's it. These are the 8 circle theorems, and under description I'm going to put the link of this page so you can study circle theorems at your leisure later. Thank you for watching.